Hello, seventh graders. It's Mr. Sarley, your new seventh grade math teacher. So if you're here, you're doing the right thing on the very first day. You're checking up on your homework, reviewing how to do some things, and just making sure you're getting it 100%. Every night, it would be great if you can come check these videos. I'm going to make one for every homework so you can really stay on top of all the things we need to learn in seventh grade. And one of those is review. So this homework is reviewing adding fractions with like and unlike denominators, and let's get started. So the first problem says 1/4 plus 2/4, and then there's two area models that are showing a picture of this fraction. So this first problem is pretty easy because both of the fractions are fourths, so they're the same type of piece. So I know my answer is also going to be fourths, and now it's really basic. The first one, there's 1/4, and in the second one, there's 2/4. Well, I know 1 plus 2 is 3, so 1/4 plus 2/4 is going to equal 1, 2, 3/4. And so that would be my very first answer. Now, the second problem is a little bit different because the pieces aren't the same type. The first fraction is the piece is 1/4, and the second fraction is an eighth. They're different sizes. So when you're trying to add things, it makes it a lot easier if you first make them the same type or the same size. So what I'm going to do is I'm going to take this 1/4 and change it into eighths by dividing it up. So I'm not changing how much is shaded, I'm just changing how big each of the pieces is. So now what I've done is I have two shaded pieces out of a total of 1, 2, 3, 4, 5, 6, 7, 8. So I just changed this fraction from 1/4, I just changed it to 2/8. And this is a review. 1/4 and 2/8 are called equivalent fractions because they look different, but they both represent the same amount. And another way to show it is you could just multiply the numerator and denominator by 2. Okay, so now it's easy because the first fraction is in eighths and the second one is in eighths. So I know my answer is going to be in eighths as well, the same size. And again, it's this one's 2 plus 1. 2/8 plus 1/8 is going to give us 1, 2, 3/8. So hopefully that's making sense. Go on to the next problem. Again, we have fourths and eighths, and you could start by drawing a picture like this. So I'm going to break it into 4 parts because it's fourths, and one of them is shaded. The second one is going to be 8 parts, so I take fourths and I break each of those up into eighths, and 3 parts out of a total of 8 are shaded. And now I'm going to do what I did with the last problem. I'm going to change the fourths into the same size as the eighths, so it's easier to add. And I'm just going to break up this picture to find an equivalent fraction. So my 1/4 turns into 2/8, and again that's the same as 1/4 and multiplying the numerator and denominator by 2. So now again it's easy to add fractions when they're the same sizes. These are both in eighths, so I know my answer is going to be in eighths. And then I have 2/8 from the first picture. Actually might help you to see it if I do the colors. So the blue's from the first picture, and the 3/8, the green, is from the second picture. And that fraction is 5/8, because each of those parts is an eighth of the whole. Okay, so those are the only ones with pictures. These last ones, I wanted to see if you could do them without a picture, but if you want to draw one, go ahead. But I'm going to use the same idea, 3/4 and 1/8. The problem is they're not the same size pieces. Fourths are bigger than eighths. So I'm first going to take 3/4 and try to turn it into eighths using equivalent fractions. And I see that I can multiply by a scale factor of 2, and I know that 3/4 will give me 6/8. So I'm going to change this into the equivalent fractions, 6/8. And now they're the same size, they're both in eighths, and in the first one we have 6 of them, in the second fraction there's 1 of them, so that's going to give us 7/8. Alright, on to the last one. This one should probably be easier for you now. Again, fourths and eighths are different size pieces, so I'm going to change this fraction 1/4 into an equivalent fraction, and I'm going to want to make it eighths again. And again, the scale factor is 2. So 1/4 is equivalent to 2/8. Get rid of that guy, 2/8. Now they're the same size. 2 of anything plus another 5 of anything is going to equal 7 of that thing. And the thing we're talking about are eighths. 2/8 and 5/8 would give us 7/8. Alright, on the back of your homeworks this week, I'm focusing on 6th grade review ratio problems, because I know with Mr. Schaefer, you guys are starting to see that 7th grade ratio problems can get kind of hard, especially because they involve fractions. So I wanted to start basic, and eventually we'll get that hard. So Pikachu, my favorite little dude, Pikachu goes driving one afternoon. He travels 40 miles every 2 hours. So 40 miles every 2 hours. I see that every, and it makes me know that this is a ratio problem. 40 miles every 2 hours. If he keeps driving at the same speed, how far does Pikachu travel in 8 hours? Alright, so I'm going to start off with a strategy you guys used a lot in 6th grade called the double number line. It was drawn a little bit like this. We always started off with 0, and then we want to label our units. And I got my units from this ratio right here, 40 miles every 2 hours. So I got miles on the top, hours on the bottom. And the first ratio I'm going to put in this double number line is 40 miles every 2 hours. Okay, and now it says if he keeps driving at the same speed, how far does Pikachu travel in 8 hours? So I know I want to scale this ratio up to 8 hours. And I'm just going to go up by the multiples of 40 and 20. So 40, 80, 2 hours, 4 hours. That makes sense because if we go up another 2 hours, Pikachu's going to go another 40 miles. And we keep scaling up like that. 6 hours, Pikachu will go 120 miles. And 8 hours, Pikachu will go 160 miles. And that's the answer we're looking for. So how far does he go in 8 hours? He goes 160 miles. Really quickly, I also want to show you the ratio table, which we also used in 6th grade. So I'm going to set that up. Again, we start with our units, miles, and hours. Then I'm going to start off with this first ratio again, the 40 miles every 2 hours. And I'm going to do what some of my students figured out back in 6th grade. An easier way to get from 2 hours to 8 hours in one swoop is to kind of multiply. And you think 2 times what will give me 8? And the answer is 4. So if I multiply this first ratio by 4, it's going to give me 160 miles in 8 hours. And now I have 2 strategies for finding the same answer. If he keeps driving at the same speed, how many hours will it take Pikachu to travel 100 miles? So the ratio they give us in the problem initially, again, was 40 miles every 2 hours. And I know right away that 40 is not gonna go into 100. So if I scale this up, I'm gonna have a problem. So one way to solve it would be at first to find the unit rate. Let's figure out how many miles Pikachu goes every 1 hour. And one way to do that is to multiply the first, or to divide the first ratio by 2. So 40 miles becomes 20 miles, and 2 hours becomes 1 hour. And so now I know something new, and I'm going to use this in my double number line. Okay, and now I'm going to scale up 1 hour at a time, so 20 miles in 1 hour, 40 in 2, 60 miles in 3, 80 miles in 4, 100 miles in 5 hours, and that's what we were trying to figure out. In 5 miles, or in 5 hours, Pikachu will go 100 miles, so the answer is 5 hours. You could have also solved this with a ratio table or using some other strategy. All right, and to prove to me that you were here, we're going to start off with the secret word, and it's one of my favorite words. It's chocolate, which is delicious. Guys, thank you for staying on top of your work, and I'll see you in class.